Welcome everybody. Today we will learn probability-based supervised machine learning algorithm, naive Bayes classification. Naive Bayes classification is the collection of classification algorithm based on Bayes theorem. Bayes theorem is a mathematical formula that describes the probability of an event based on prior knowledge of conditions that might be related to that event. It is derived from the conditional probability. Conditional probability is a measure of the probability of an event occurring given that another event is already known to have occurred. It is denoted by P of A bar B. Conditional probability is given by the following formula. It is equal to the ratio of probability of occurrence of both the events A and B to the probability of event B, where P of A bar B is the conditional probability of event A given that event B has occurred. P of A intersection B is the probability that both events A and B occur. It is the intersection of A and B. P of B is the probability of event B occurring. Conditional probability can be explained by the following. It is the probability of A given B. It is the proportion of A and B in B. The pipeline symbol is referred by the word flags if, or, given, or, of the. P of A bar B is called as probability of A if B, or probability of A given B, or probability of A of the B. According to the multiplication rule of probability, the probability of occurrence of both the events A and B is equal to the product of the probability of A and the conditional probability that event B occurs given that event A occurred. Generalization of multiplication rule for n events is given here. Probability of occurrence of n events together is given by this equation, where P of A1 is the probability of event A1 occurring, P of A2 given A1 is the conditional probability of event A2 occurring given that event A1 has already occurred. P of A3 given A1 intersection A2 is the conditional probability of event A3 occurring given that events A1 and A2 have occurred, and so on. For independent events, the probability of occurrence of both the events A and B is equal to the product of the probability of A and the probability of B. Generalization of multiplication rule for n independent events is given here. Probability of occurrence of n events together is given by this equation, where P of A1 is the probability of event A1 occurring, P of A2 is the probability of event A2 occurring, P of A3 is the probability of event A3 occurring, and so on. Bayes theorem is derived from the conditional probability. It is the probability of event A happening based on new information provided by the occurrence of event B. By conditional probability, the probability of occurrence of both A and B is equal to the product of the probability of A and the probability of B given A, or it is equal to the product of the probability of B and the probability of A given B. From this, the Bayes theorem formula for the conditional probability of A given B is the ratio of the product of probability of B and probability of A given B to the probability of A. P of A is the initial probability before considering any new evidence. In the context of classification, Bayes theorem can be used to calculate the probability of a particular class C given a set of features F. The formula is as follows. The conditional probability of class C given that set of features F has occurred is the ratio of the product of probability of class C and the probability of feature set F occurring given the class C occurred to the probability of feature set occurring. For a set of n features, Bayes theorem is defined as the conditional probability of class C given features F1, F2 up to Fn is the ratio of the product of the probability of class C and the probability of features F1, F2 up to Fn given class C to the probability of features F1, F2 up to Fn. Naive Bayes algorithm is a classification algorithm based on Bayes' theorem, making naive assumptions. There are two naive assumptions made by the naive Bayes classification algorithm. First one is occurrence of any one feature is independent of the occurrence of the other features. Second assumption is each feature makes equal contribution. Let us assume the example of classification of fruits. The input features given to the classifier are color, shape and taste of a fruit. The occurrence of each feature is independent of one another and they are making equal contribution. Naive Bayes theorem is based on the conditional probability of independent events. By the multiplication rule of independent events, probability of A intersection B is the product of probability of A and probability of B. As the features are conditionally independent, for n features, the likelihood or probability of occurrence of all features for class C is given by the product of probability of occurrence of each feature given that class C has occurred. By Bayes' theorem, the probability of occurrence of class C with the occurrence of features f1, f2 up to fn is given by the ratio of the product of probability of class C and the probability of feature set f given class C to the probability of feature set occurring. Naive Bayes classification is a supervised machine learning. Naive Bayes classification has two phases. They are the training phase and the classification phase. Let us see the training phase of the naive Bayes classification. We use the training data to compute the necessary probabilities for the chosen naive Bayes model. Initially, naive Bayes model is presented with a labeled dataset S with features F and the class label C. Next, the probabilities for each class based on the training dataset P of C1, P of C2, etc. are calculated. For each features F1, F2 and so on, and each class C1, C2 and so on, the conditional probability given that the class P of F1 bar C1, P of F1 bar C2, etc. and P of F2 bar C1, P of F2 bar C2 and so on are estimated. Now we will see how naive Bayes model is used for classification. For each instance in a new dataset with features fn1, fn2, etc., the likelihood of observing these features for each class is chosen. Bayes' theorem is applied to calculate the probabilities for each class. The class to which the given instance belongs is predicted by selecting the one with the highest probability. We have seen how naive Bayes model is built using the given data set and how it is used for classification. Thank you. Thank you for your patient listening.